Same background. So we're going to identify, oops, you know what? Typo. Identify the graph of parent functions and state its domain and range based on the graph. So these are going to be the parent functions, and then when you get to the next page, the parent function is going to be transformed, and you're going to have to match it with which it started as and state the new domain and range. So we're still practicing domain and range. Remember, domain is your allowable x values. Range is your allowable y values. I think some of you that retook the test yesterday were still confusing domain with range. So anyway, we need to keep practicing domain and range, I think. So a linear function is just y equals x, right? Y equals x. We know that as y equals mx plus b, right? It's just a linear function. X is to the first power. But the parent graph just has a slope of 1, and it goes through the origin, right? Because it's really y equals 1x plus 0 if I wrote it out. So you start at 0, 0, and it just goes up 1 over 1, right? That's the parent function of a linear graph. Parent function of a linear graph. Then you can shift it up, down, left, right, change the slope. Can anyone tell me if you remember, but what would be the domain and range of a linear function? Both of them are going to be all real numbers. So you can either write that as kind of that bold-faced capital R, or just all real numbers, whatever one you like better. So x can be anything and y can be anything. Because when I scan left to right, kind of all the points are included. When I scan up and down, all the y values are included. Quadratic function is our deep dive for this unit. So right now we're just calling that y equals x squared. If I was going to set up a table of values, though, for x and y, in case I don't know what x squared looks like, the key points, like if I did -2, -1, 0, 1, and 2, what would be the y values when I square them? So anything times itself gives you a positive answer, right? So -2 times -2 is +4. -1 times -1 is +1. 0 squared is 0, 1 and 4. So it ends up giving you this parabola, right? Over 1 up 1, over 2 up 4. So we're going to look at this graph a lot more this unit, but kind of recognizing what the inputs are, how you get your output. What would be your domain and range for your quadratic function, do you think? Yep. Yep, so y is greater than or equal to 0, right? Because it could be at 0, 0. So when I scan left to right, I have a function everywhere, but when I scan up and down, I have no negative y values. So that could change if I flip this graph upside down, but the parent function, the range is y is greater than or equal to 0. Seem okay so far? So one other thing I wanted to mention, quadratic is x squared. On that homework assignment 009, I checked most of your answers, but one of the questions, part C, is the function exponential, quadratic, or linear. That one's linear, x plus 2. 2 to the x power is exponential, but x squared is quadratic. So knowing the difference between linear, exponential, and quadratic is a huge concept that you want to have mastered by the end of Algebra 2. But we're not mistaking those anymore because we're studying quadratics in this unit. X squared is quadratic because x is being squared. Okay, so cubic function is x cubed. And so if you've never seen a cubic function before, you could kind of do, the same thing we just did. Let's do a few values around the origin and see what we get. So when x is -2, -1, 0, 1, and 2, and you cube a number, can you guys see this okay? There, maybe that's better. So when you cube a number, you're multiplying it by itself 3 times. What's -2 times -2 times -2? Finn? -8, right? So a negative times itself 3 times will produce a negative result. So -1 cubed would be -1. 0 times anything is 0. So 0 times 0 times 0 is 0. 1 cubed is 1, and 2 cubed would be 8. So this graph kind of snakes its way through the origin. So 0, 0, 1, 1. 2, 8 is way up here. And then it kind of has origin symmetry. So snakes its way to -1, -1, and then -2, -8. So it's a curved graph. This is the parent function. But if you see a graph that kind of looks like this is kind of an exaggerated cubic function. So instead of just x cubed, there's something else. X cubed plus 2x squared plus 3x minus 5. It produces these like more exaggerated kind of bumps and turning points. So if you see that, know that that's a cubic function. What do you think the domain and range are for the cubic function? They're both all real numbers. So I have no restriction on what I can plug in for x, and y keeps going up and down all the way. But that's probably a new function for you this year. I don't think you spent a lot of time on cubic functions. So just being able to take this parent function and shift it up, down, left, right, flip it over, that's kind of the idea of the transformation rules. So knowing these key points or producing them with a table and being able to shift them all to the right or all to the left, and knowing what the equation would look like when it shifted left or up or down. All right, so the square root function is the square root of x. This is probably a new one for you too. So -2, -1, 0, 1, and 2, if I keep those points around the origin, what happens when I plug in -2? Error or undefined, right? So undefined at -2, undefined at -1, because I can't take the square root of a negative number, because a square root is asking you what number times itself will get you back to what you started with. Two numbers being multiplied will always be positive, not negative. All right, so I can do the square root of 0, right? The square root of 0 is 0, because 0 times 0 will get you back to 0. What's the square? Oh, shoot, I shouldn't do the square root of 2. Well, what's the square root of 1? 1. The square root of 2 is a number. It's just irrational. So I'm allowed to take the square root of 2, but I get, oops, you can't see that, 1.41421, etc. So I could do the square root of 2 as 1.4. I usually skip to the next perfect square. So what would be the next perfect square? Yeah, so from geometry, the next perfect square is 4. What would be the next perfect square after that? 9. So I have perfect squares up here, and in trig, you've probably been talking about them, but I can take the square root of 1, 4, 9, 16, 25, and get integers 1, 2, 3, 4, 5. So we know that the square root of 4 is 2, the square root of 9 is 3, right? So when you're plotting them, I usually leave out that 2, 1.4, because it's not a perfect square, but you could graph it. Starts at the origin and slowly goes up as half of a parabola, basically. It's like half a sideways parabola. Over 1 up 1, over 2 up 4, or sorry, over 4 up 2, over 9 up 3. Anyone want to take a stab at the domain and range? Yep, greater than or equal to 0. Yep, because I can't plug in any negative x values. And what would you say, Adam, for the range? Same. It's only going to produce values that are greater than or equal to 0. So that's another new function that may take a little bit of practice to figure out. So cubic and square root, you'll see those with the transformation practice. Good on that one? So there's a few left on the back. Exponential, we're not going to really focus on their graphs. It's nice to be able to recognize the graph, maybe recognize the equation and what's happened to it, but I'm not going to go really deep into graphing these because we'll see them again in the exponential unit. So, I mean, these are really not a focus. You know, so if I'm asking you transformation rules, I'm probably not going to pick exponential a lot of the time. I'm going to pick 2 to the x as my function, but it could really be 3 to the x or 4 to the x. So exponential increasing, this base has to be bigger than 1. Exponential decreasing, it's going to be a fraction, like 1/2 to the x or 1/3 to the x. So when we were doing the radioactive dice and they were decreasing, right, we had like, I don't know, the ratio was 0.86 or something like that. That would be exponential decreasing. When we're talking about population growth or getting more money in your bank account, those are exponential increasing. So, I mean, there's one key point that we will talk about, but when I plug in 0, anything to the 0 power is 1. So it's nice to know that 0, 1 is a key point, so that when you shift it all around, if you just find out where that point moved to, you know what happened to the graph. Same thing on this one. So even if it's a fraction, anything to the 0 power is 1, 0, 1. Did anyone ever show you why that is? And it's not just like, oh, that's a math fact. It has to be. I mean, if you do it on the calculator, 2 to the 0 power is 1, right? So why did they make it so anything to the 0 power is 1? So just to prove it to you, the whole point of an exponential function is like you're multiplying something by 2 every time, right? So 2 to the first would be 2. You don't have to write this down, but 2 squared is 4, 2 cubed is 8, 2 to the fourth is 16, 2 to the fifth is 32. All I'm doing is multiplying by 2 every time, right? So what about 2 to the 0 power, 2 to the negative first, 2 to the negative second, 2 to the negative third? It just continues this pattern. So if I'm multiplying by 2 in this direction, I'm actually dividing by 2 in this direction. So isn't 2 divided by 2 1? And then 1 divided by 2 would be a half. A half divided by 2 is a fourth. A fourth divided by 2 is 1/8. So the 0 exponent rule is kind of that one placeholder. If you made it a 0, it would like throw off the whole pattern because 0 times anything is 0. So same thing, if you went through this with 3s, you would always have that like 3 divided by 3 is 1. 4 divided by 4 is 1. And then the fractional exponent or the negative exponents turn it into a fraction. I think you can see just because the powers, right? You're still dividing by 2 every time. So if you think of exponential functions as a pattern, I think that 0, 1 makes sense. There is something called an asymptote at y equals 0. Not something that's super important for this unit, but when we graph exponential functions, we'll be putting that asymptote in when it moves around. Anyone want to take a stab at the domain and range for these functions? Yep, so the domain is all real numbers because my graph extends from left to right. I can plug in negatives or positives. Yeah, but my range is going to be strictly greater than 0. So this thing called an asymptote, you'll see it in trig this year too if you graph the trig functions. Your graph has to hover above that. So I never get to 0, right? Because I'm 32, 16 down here into these fractions. This fraction might get down to like 1 over a million, right? Or however many zeros a million would be. There you go. Even 1 over a million is not 0, right? So I keep cutting it in half. I never get to 0. All right, and then the last one, before we go for a little walk outside and we can come back and do the practice problems. Yeah. So let's see. Absolute value. We haven't graphed that one yet. We're going to do a day on this during your, I think it's tomorrow, actually. Absolute value functions, tomorrow. If you make a chart x, y, -2, -1, 0, 1, and 2, does anyone know the definition of absolute value? Yep, the distance you are away from 0 on the number line. So if x is -2. How far away from 0 is that? It's a distance of 2. So distance is always a positive amount. So I would be 2 away from 0, 1 away from 0, 0 away, and then 1 away and 2 away. So absolute value makes what's inside it basically the positive distance. So when you graph these points, you get a vertex at 0, 0, and kind of this V-shaped graph with a slope of 1 in this direction and a slope of -1 in this direction. So it's a V-shaped graph at the origin. We'll see it in depth again tomorrow, plotting the points, practicing transformations. What would you say the domain and range are for absolute value? Yep, y is greater than or equal to 0. So hopefully, even though Adam's answering, you guys are ahhing, right, that you're understanding what domain and range are, hopefully. So I just want to show you 1 and 2 at the bottom so that when we come back in, you can try 1 through 6 on your own on the next page. So we are going to just decide which parent function this is and then state the domain and range. And that's what we're going to do on the next page too. So what parent function is that on the first one? Quadratic, because it's a parabola, right? So someone different. Willem, what would be my domain? Yep. So when you look left to right, what would you say? Perfect. Someone else, what do you think the range is for this function? Kaya, what do you think? Yeah, y is greater than or equal to -2. See how -2 is the bottom of the graph right there? So the graph doesn't go anywhere below -2. So y is greater than or equal to -2 would be the range. All right, so Chinoa, what parent function do you think that is from those 7 choices?